Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. We are going to talk about something called expected value today. And understanding expected value can really help you make the best life choices throughout the day because it's essentially going to tell you whether one choice is more valuable than another. And, it doesn't necessarily have to be monetary value, right? You may think, okay, this choice is going to be better for me in terms of money, but maybe you want to calculate, is it better in terms of happiness? Or is it better in terms of points being scored on a test or goals being scored in a game, etc. So if you know how to calculate expected value, essentially it just gives you more confidence that the choices you're making are the best ones for you at that given point in time. Let's look at this introduction problem to start us off. It says Jack found a winning lottery ticket on the ground. The winning amount was for $30. Now we're going to assume Jack tried to turn it in, but they couldn't find the actual owner, so Jack is fully justified in keeping this ticket. Nothing unethical going on here. Jill decides to offer Jack a proposition. She says that she will give Jack a chance to win more money if he gives her the lottery ticket. She puts 6 brown bags in front of him, filled with the following amounts: $0, $0, $1, $1, $10, and $200. If Jack gives her the lottery ticket, then she will let him pick and keep one of the bags. Should Jack take the deal? Why or why not? Well, pause the video. Think about whether it would be better for him to keep the $30 ticket or whether it would be better for him to choose one of the bags and keep the amount inside. And try to have a good mathematical reason for what you're choosing. Okay, so the answer here is actually he should pick one of the bags. And he should give Jill the lottery ticket because picking one of the bags turns out to have more or a higher expected value in terms of dollars than keeping the lottery ticket does. Now, you may say, well, there's only one amount higher than $30 in the brown paper bag. And that's true, right? Most of the time, he's going to walk away with less than $30. But that one time where he gets $200 out of 6, that more than makes up for the other times where he wouldn't pick the $200 amount. One of the ways we can figure out just how valuable it is for him to pick the bag is we can find the amount of money he makes on average by choosing the brown bags. Well, to do that, we would just find the average dollar amount in each bag. 0 plus 0 plus 1 plus 1 plus 10 plus 200. Right? That's the total amount of money in all the bags. If we divide by 6, well, that gives us 212 divided by 6. That gives us approximately $35.33. So you can see that by choosing the brown paper bags, Jack makes about an extra $5.33 on average. Now again, he's not going to make that exactly every time because a lot of times he's going to make less than $30. But there is one time where he makes much more than $30. He gets $200. So with all things being held equal, he should definitely choose the brown paper bag because it's a more valuable option than just keeping the lottery ticket. So expected value, the definition, is the average value of a variable. And that's what we're going to practice calculating today. It's just the expected value of different decisions. Let's look at this problem number 1 down below. Now, expected value is so important in many different areas as far as career paths go, right? Businesses use it, sports teams use it, teachers use it, individuals use it. So it is something important to know. And again, just on an individual level, on a personal level, it's valuable because, like I said at the beginning, it can give you more confidence that the decisions you're making are in your best interest, right? If Jack didn't know much math, well, he would just be taking a guess at whether that choice of choosing the brown bags or keeping the lottery ticket which was the best one, right? But if he understands some basic math, he can be confident that choosing the brown paper bags is correct, even though he's going to walk away with less money most of the time. He can still be confident that his choice was best in the long run. Let's look at this example dealing with an exam. It says Darian has a final exam that is made up of 15 multiple choice questions, 10 short answer, and 20 true or false. True or false are not my favorite type of question, but I digress. All questions are worth 1 point. If Darian has a 0.6 probability of getting each multiple choice question correct, 0.4 probability of getting each short answer correct, and a 0.7 probability of getting each true or false answer correct, what can Darian expect to score on his test? Well, it seems kind of complicated here at first, but if we break this down, we can come up with the expected value, or the expected score that Darian will get. Well, let's break it down by category. Let's do multiple choice questions first. Well, there's 15 multiple choice questions. They're each worth 1 point. So there's 15 multiple choice points total. If he's got a 0.6 probability of getting each one correct, well, we can multiply 15 by 0.6. If we do that, we end up getting 9. So on average, we would expect Darian to get 9 questions correct from the multiple choice section, which would give him 9 points from that section. Maybe you want to pause the video and continue this problem now that you kind of see what we're doing. But let's look at the short answer section. We'll call that SA. 10 short answer questions are each worth 1 point. So if there's 10 questions and he has a 0.4 probability of getting each one correct, 10 times 0.4 gives us 4. So we can expect him to get 4 short answer questions correct. They're all worth 1 point, so we can expect 4 points from this section. Let's go with true or false. Well, there's 20 of these questions, and Darian has a 0.7 probability of getting each of these correct. Well, 20 times 0.7, that gives us 14. So he can expect to get 14 of the true or false questions correct. They're each worth 1 point, so he can expect to score 14 points in that section. Now, that's the average expected score from each section. Well, the average expected score from the entire test would just mean we add up all these different expected values. This ends up giving us 27. Darian can expect to score 27 points total on the test. And if they could ask you further questions like, what are his chances at a passing grade? Well, then you would compare 27 to the total and figure out what would be a D, an F, a C, etc. But we can stop here because that's all this question asks us. What would he expect to score? Well, he would expect to score 27 points on average. Let's jump to the next page, where we're going to look at the expected value formula. It's going to look a little complicated to you, but that's why we did an example first, to kind of show you that it's not as hard or as complicated as you think finding expected value. So expected value is equal to x sub 1 times p sub 1, where x is the value of each outcome and p is the probability of each outcome. So this just represents, right here, the value of each of the first outcome, right? The expected value of the first outcome. We could think of this as like the multiple choice section from the top, right? So we found the expected value of the multiple choice section. We figured that, I think we said that Darian would earn 9 points from that section on average. We added that to the expected value of the short answer section. Right, I think we found that he would earn about 4 points on average from that section. And then we had a third section, right, the true or false, and we figured that he would earn about 14 points from that section. Now, in our example above, we had 3 different categories or outcomes we needed to look at. There could be more, there could be less. The idea is, though, right, that you find the expected value for each individual outcome, and then you just add them all together to find the total expected value. So don't think too much about this formula. Just think about the idea, right? For every outcome that you have, find the expected value of that, then do that for each outcome that's possible, and then add them all together. Let's do 1 or 2 more examples, again, to kind of solidify this process, this idea of expected value. There are a bunch of examples that you can apply this concept to. Let's look at number 2, though. So it says Rachel's looking at a mutual fund to invest in. She has $10,000 to invest. There's a probability of 0.4 that the fund will earn her a return of 30%, a probability of 0.5 that the fund will earn her a return of 10%, and a probability of 0.1 that she will lose 15% on her investment. If she invests, what can she expect her total profit or loss to be, not including her original investment? Okay, so let's just break this down. Right, instead of trying to put this all into one equation, let's just break it down by its parts. Well, we have an outcome where she makes 30%. Well, we need to figure out what that dollar amount is, right? If she makes 30% on 10,000, we would do 10,000 times 30%, or 0.3. That's going to give me $3,000. So if she earns 30%, she's going to make $3,000. But that's not happening all the time, right? That's only happening with a probability of 0.4. So we take that 3,000, we multiply by 0.4, and that gives us $1,200. So this is our expected value from the 30% option, right? It's only going to happen with a probability of 0.4 or 40% of the time. Now there's another option. It's where the fund returns her 10%. Well, if she makes 10% on 10,000, multiply by 0.1, that gives us 1,000. 1,000 times a probability of 0.5, right? It says 0.5 probability that the fund will return her 10%. So that gives us $500. So our expected value from that 10% option is $500. And then there's the option that she loses 15%. So minus 15%. So I need to make sure I multiply this 10,000 by negative 0.15, because this represents a loss, and this would be negative $1,500. This happens with a probability of 0.1. So negative 1,500 times 0.1, that's going to be equal to negative $150. So these are all the expected values of the different options. Well, now we need to add them together to see which, or not to see which, but to see what her overall expected value would be. Well, 1,200 plus 500 is 1,700, plus negative 150 gives me 1,550. So on average, this mutual fund would return her $1,550 after 1 year, which is actually a really phenomenal return. It's about, it's exactly 15.5%. And if you can find a mutual fund that on average gives you 15.5%, you should put almost all of your money in it, because that is extremely good. But you can see, right, this is a very real world example that you guys don't really have to think about right now, because you're still in school. You're not really at the point where, you have a career where you're thinking about investing money every month or every year. But eventually, right, when you have a job and you start getting a a healthy paycheck every 2 weeks or every week or every month, you want to think about how can I make that money grow? And one of the ways is investing. But if you have no idea about, how math works or expected value works, well, you may not know which funds are the best to invest your money in. You may not know which stocks you should buy. That's a whole other question of whether you should buy individual stocks or mutual funds. Question for another day, another class. But at the very basic level, you want to understand which funds are better, right? Which stocks are better. And you can do that by calculating expected value. You never know exactly what's going to happen with a stock or with a mutual fund, but you can use previous data to make pretty good predictions about what may happen. And the people that understand how to make those predictions are generally going to make more money than others. So you're always asking, what can math do for me? Math can make you a lot of money, or it can save you from losing a lot of money, right? By not investing in a bad fund or a bad stock. Okay, let's see. Do we want to do another one, or do we want to call the video here? We're going to call the video here, and we're going to save the rest of these problems for in class. As always, enjoy the rest of your day, and we will look forward to seeing you next time.